All right. So we are starting 10.7, which is parametric equations. And you see this etch a sketch here. So a parametric equation is talking about we're essentially three variables. So normally we just have x and y. So here is x, there's y, and then maybe if I can do it is a straight line. Okay, so we could do that. But what happens if I want like the flight of a bumblebee? Okay, and bear with me here. Etch a sketch is not my thing. So if I want the flight of a bumblebee, oops, no, I want it to make a circle. Ah, okay, well, let's try again. Okay, so here's the flight of my bumblebee. It goes shoo, and then it circles around and it comes up and it goes down and it comes up and it goes back around. How do I give x and y coordinates for this? Well, we're going to say time. So time is going to be, we're going to do like, here we go. X is going to be f of time and y is going to be g of time. So at time 1 second, here's my xy coordinate. At time 2 second, 3 second, 4 second, 5 second, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're going to talk about how can I write a parametric equation that's going to give me a graph like this, or how can I do this? So here we go. Parametric equations are x and y coordinates of points on a curve can be given separately as functions of an additional variable, and we'll call that variable t, called the parameter. So we're going to have f equals f of t, or sorry, x equals f of t, and y equals g of t. These are called parametric equations for the curve. Substituting a value of t into both equations determines the coordinate of the point x of t, comma, y of t. As t varies, the point varies and traces out the curve. So here we have two equations. My x is going to be t cubed, and my y is going to be t minus 1. Now, we have to be careful if we're looking at a real world problem. What is t describing? Can t be negative? Can it be positive? But for this, since there's nothing that really has restrictions, I'm going to look at both my positive and negative values of t. I'm going to say -3, -2, -1, 0, 1, 2, 3. And for x, if I plug in -3 cubed gives me -27. And I'm going to continue down on x. So -2 cubed is -8. -1 cubed is -1. 0 cubed, 1 cubed, 2 cubed, 3 cubed. Okay, and then I'm going to do the same for y. Y equals t minus 1, so -3 minus 1. And then we'll go to t minus 1, where t is -2, so -2 minus 1. -1 minus 1. 0 minus 1. 1 minus 1. 2 minus 1. And 3 minus 1. Now, if I go to graph this, I'm graphing the x of t, comma, y of t. So I'm graphing these two. Okay, so let's see. At -3, at x equals -3, or no, sorry, at x equals -27, I'm at y equals -4 off my graph. X equals -8. Let's see, does it go that far? 1, 2, 3, 4. Oh, I can't see that very good. 1, 2, 3, 4, 5, 6, 7, 8. It does. 8, -3. 1, 2, 3. There's the dot there. At x equals -1, y is at -2. At x equals 0, y is at -1. At x equals 1, y is at 0. At x equals 8, y is at 1. Let's see, 1, 2, 3, 4, 5, 6. Y is at 1. Okay. And I'm going to connect my dots. Okay. And so they look like that. And by following the pattern, I could see that it's going to go on and on in both directions forever. Well, that's great. But let's look at one that's maybe a little bit different. Okay, so let's look at one that has our trigonometric graphs on it. So x is going to be defined as sine of t. Y is going to be defined as 1 minus 2 sine squared t. And in order to make things a little prettier, when I choose my t values, I'm going to choose values that I know on the unit circle. So I'm going to do 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi, just to make things easier for me when I plug them in. Okay, so I'm going to start with x. Sine of 0 is 0. Sine of pi over 4 is root 2 over 2. But since I'm putting this on that, I'm going to call that 0.7. Because root 2 over 2 is about 0.707. Okay. Sine of pi is 1. Sine of 3 pi over 4 is your 0.7 again. And then at pi, we're 0. 5 pi over 4, we're your negative 0.7. 3 pi over 2, negative 1. 7 pi, that's 7 pi over 4. 7 pi over 4, negative 0.7. And 2 pi, we're back to 0. Okay, so those are our x of t values. Our y of t is going to be 1 minus 2 sine squared t. Oh, okay. So let's take a look at that. Okay, so here we're going to be looking at 1 minus 2 sine squared of 0. So that's going to be 2 times 0. So 1 minus 0 is 1. Here, we're looking at 1 minus 2 sine squared of pi over 4. Pi over 4, sine pi over 4, we said was root 2 over 2 squared. So that's going to be 2 over 4 times 2. Is going to be 1. 1 minus 1 is 0. Whew, that was rough. Okay, so here We know that sine of pi over 2 is 1. So I'm going to take 1 minus 2 times 1 squared. So 1 minus 2 is negative 1. Okay, we kind of see a pattern here. So we're going to be back to 0, 1, 0, negative 1, 0, 1. So notice here I was using the root 2 over 2 to get exact amounts. So there's where we're at there. Now let's go to try to plot this. And because, I have old lady eyes, let's call this negative 0.25. So 1. We'll call this negative 1. Call this 1, 1, negative 1. Just to kind of space things out a little bit. So each piece is a quarter. Okay. So when x is 0, y is 1. When x is 0.7, y is 0. When x is 1, y is negative 1. When x is 0.7, y is 0. Oh, interesting. We're plotting right on top of ourselves again. When x is 0, y is 1. When x is negative 0.7, y is 0. Oh, I need to move that over. Instead of quarter, so 1, 2, 3, 4. Okay, so when x is negative 0.7, we're there. Negative 1, negative 1, negative 0.7, 0, 0, 1. So do you see something that's happening? Let's watch. If I connected my dots, I started here and I went here, 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 here. So do you notice how I have some bounds? Okay. What I want you to notice is that I'm not going beyond negative 1 and 1, and I'm not going beyond negative 1 and 1. So when we have some t values, we could get some restrictions there if we're using trig functions. And we'll talk about that more in the next example.